So now we've done ethane, let's go to a more fun molecule, butane. Now, of course, you might say butane has got 3 carbon-carbon bonds. Or quite frankly, once we're done with ethane, the rotation of 3 hydrogens around this carbon-carbon or this carbon-carbon, dead boring. What we actually want to think about is the rotation around that central carbon-carbon bond. Now, seeing as how we're interested in these 2 carbons, all we have to think about is everything in terms of those 2 carbons. So this carbon here bonds to a hydrogen and a carbon with 3 hydrogens, but it doesn't care what that carbon's bonded to. So we'll just say that that's not really a C with 3 hydrogens bonded to it. It's a CH3 group. Now, to make it even more fun, there are common abbreviations associated with little branches like this. So we can think of this CH3 not as being part of that longer chain, which of course it was for butane, but we just think of CH3 as a group attached to this carbon in the same way that we would have thought about branches off longer chains being attached to that chain. So when we do that, we say, well, this is a 1 carbon branch, a 1 carbon group. 1 carbon is called a methyl, so we'll abbreviate it Me. And there are some abbreviations, common abbreviations, that you do need to be familiar with, that you'll see time and time again, that just make it easier and less messy to describe certain groups. So obviously methyl CH3, Me ethyl CH3CH2, Et propyl CH3CH2CH, bonded as a nice 3 carbon chain, Pr or NPR. Now, where propane doesn't have isomers, propyl as a group does, because you can either bond through this N carbon or you can bond through the middle carbon. When it's the end carbon, it's N-propyl. When it's the middle carbon, you call it isopropyl because it's an isomer of propyl. So there's 2 3 carbon chains, branches, 3 carbon groups, however you want to call it. One where the group is bonded at the end, so it's just a nice 3 carbon chain. The other one where it's kind of a little fork, you've got a carbon there and then 2 methyls coming off that carbon. Now when we go to butyl, it's even more fun. There's N-butyl, which is a 4 carbon chain as a group, just bonded through the end carbon there. Or we can have an isomer of butyl, which is this one here. Again, an end carbon, but instead of it being a 4 carbon chain, it's a 3 carbon chain with a methyl group coming off it. So this is isobutyl, or I-butyl for short. Now in both of these, butyl and isobutyl, the carbon that's attached is a primary carbon. But we can have an isomer where it's a secondary carbon that's attached. You see this carbon here that's bonded to whatever else is bonded to, has a methyl and an ethyl off it, is bonded to 2 carbons, so therefore it's a secondary carbon. And then my favorite big group is where it's a butyl, again 1, 2, 3, 4 carbons in the branch, in the group, whatever we're calling it, but now the carbon that's bonded to the rest of everything is a tertiary carbon. It's got 1, 2, 3 carbon atoms. So do be familiar with these abbreviations. There wasn't a really good time to introduce it beforehand because we need to talk about isomers, we need to talk about secondary and tertiary, but anyway, there it is. Learn those abbreviations. But anyway, back to the main event. Butane. Now here we've got a color-coded butane in much the same way that I color-coded previously. So you've got 1 carbon that's got a couple of grey bonds and a couple of, it will be grey hydrogens here. And then the other carbon, we've got purple bonds and purple hydrogens. But in this case, unlike ethane, the other thing bonded on is not a hydrogen, it's a methyl group. And I want to make it very, very clear what those methyl groups are. So therefore, here is my picture of butane. Here's my model of it. And it's in an eclipsed position in the front carbon. So that's the little purple Mercedes-Benz symbol. Again, I've got a green hydrogen, a green hydrogen, a green hydrogen, a green hydrogen. But then this top one here is a big purple ball, right? That is the methyl group that's hanging off that front carbon. And behind it, you can see the yellow ball. That is this orange methyl group, and of course it's right behind it, so therefore we put it in brackets. So methyl eclipsing methyl, green hydrogen eclipsing silver hydrogen on the left, green hydrogen eclipsing silver hydrogen on the right. And so as I did last time, I'm now going to do some rotations. Now last time I only needed to do one 60-degree rotation to go from eclipsed to staggered. What we'll see here is that there's actually the need to do 3 rotations to go 60 degrees, 120 degrees, and then 180 degrees in order to get all of the interesting conformations. So let me see if I can do my usual not messing up with the video. So there it is right there starting off. Excuse my big fingers getting in the way, but you can hopefully see that the model on the video here is the model right there. So now let me continue on playing it, rotating it by 60 degrees. Okay, so now you can see this scenario here. Again, I'm not touching the front carbons, I'm just rotating the back carbon. So we see again the front carbon methyl at the top, 2 hydrogens in that Mercedes-Benz. But now I've rotated by 60 degrees, so I've taken the big yellow methyl that's on the back carbon around here by 60 degrees to get to this staggered situation. Okay, so 60-degree rotation from the eclipsed to the staggered. So now the methyl, it's not behind, the back methyl is not behind the front methyl, it's kind of one around from it. So now let me continue with the rotation. Another 60 degrees, and that gets me back to this, again, an eclipsed situation. Front purple methyl there, the front again untouched, so the purple methyl on top, green hydrogen. But now the eclipse, this methyl group on the back has come around 120 degrees, so it's no longer being eclipsed by the other methyl, as it was here, it's being eclipsed by one of the hydrogens, and this purple methyl is eclipsing a hydrogen, you can see it back there, rather than eclipsing the methyl. So we start off here, call it 0 degrees with an eclipsed, we rotate by 60, and we get a staggered, in which the methyl is 60 degrees around on the back from the front, go another 60 degrees, and now the back methyl is now eclipsed by a hydrogen. So let me go back up to the video, press play, and let me rotate again by another 60 degrees, so I get this picture here. So now again, front one untouched, methyl at the top, hydrogens on the 2 bottom spokes, but now on the back one, my yellow methyl is now 180 degrees around from the purple methyl. So again, start off here at 0, eclipsed, go round 60 degrees to a staggered with the methyl 60 degrees round, another 60 degrees, another eclipsed, but with the back methyl being eclipsed by hydrogen, go another 60 degrees round, so now I've gone a full 180 degrees, and now my methyl group on the back is as far away from the methyl group on the front as can be. So match up our Newman projections here. Okay. Now, these are therefore 4 fun conformations. Start off with the eclipsed one. We can have the eclipsed where the back methyl is eclipsed by the methyl group, or whether it's eclipsed by a hydrogen. It's not a full name that I'm aware of to distinguish between these, so I'm just going to call it eclipsed versus totally eclipsed. So the eclipsed where the methyl is behind a hydrogen, totally eclipsed where the back methyl is behind a methyl. There's other fancy names that we could bring in, but quite frankly not at this level of the class. However, the names associated with the 2 staggered ones are important, because the staggered, the methyl can either be 60 degrees around, as the case here, or 180 degrees around, as the case here. 60 degrees is called gauche, 180 degrees is called anti. And that anti arrangement there is something we will see several times as we keep going through reactions and reaction mechanisms. So there are the 4 important conformations associated with butane, not just eclipsed and staggered as we saw with ethane, but totally eclipsed or just eclipsed depending upon where the back methyl is relative to the front methyl, or staggered could be gauche or anti, again based on where the back methyl is relative to the front methyl. Now I should point out, if I keep rotating, so we left off here, if I rotate another 60 degrees, think about where this back methyl is, then the methyl will go here, so that would just be another eclipsed. Another 60 degrees would take that methyl here, so that would be another gauche, and then another 60 degrees would take the back methyl to where we started. Okay, butane, fun to see with models. Hopefully my video has at least illustrated this to some degree. Conformations, great fun, rotating around bonds so that you get different structures for the same molecule. In the extension for this material, I talk more about the energies associated with the different conformations of butane, amongst other things.